Hey everyone, welcome. This is Defending and Investigating Hypervisors. Thanks for joining us today. My name is Anurag, and I'm a manager with the CrowdStrike IR team based out of Melbourne here in Australia. I'm also a SANS certified instructor, and with me I have my colleague Thiru.
Hi everyone, this is Thiru from Singapore. I'm a senior manager in Mandiant Consulting, now part of Google Cloud. We predominantly support our customers to respond and remediate to major security breaches and to proactively assess the security posture of their environment. Nice to meet you all today.
Okay, let's get started. So what are we going to talk about today? We'll talk about bare metal hypervisors. We'll talk about threat actor techniques and tactics when they target these hypervisors. And then we'll deep dive into how can we investigate the threat actor activity. We'll also talk about defending hypervisors and how defenders can make sure that the threat actors cannot access the hypervisors. What is an hypervisor? Hypervisor is a software that allows multiple virtual machines, we're going to call them guest machines, to run over it. The bare metal hypervisors are the one that directly run over the hardware. So there is no operating system in between the hypervisor and the machine which it is running on. But then the question is, why are we talking about these hypervisors? Hypervisors support most of the critical infrastructure and critical workloads in modern enterprise environments. They are often more critical than your Active Directory domain controllers and other infrastructure which supports organizations. Another reason is that these systems often have very low visibility. There is often no endpoint security software, no EDRs that can run over it, and defenders do not have much access to what's happening on these boxes. And both e-crime as well as nation-state threat actors have been consistently targeting these hypervisors. E-crime threat actors to perform encryption at scale, and we'll talk about that more. Nation-state threat actors because they want to maintain that covert access into these hypervisors to access the environment as well as to interact with guest virtual machines which run on these hypervisors. The biggest dog in the town and the biggest player when it comes to hypervisors is VMware. So VMware's vSphere solution consists of the VMware ESXi, which is the hypervisor, the bare metal hypervisor, and then there is vCenter. vCenter is a centralized server that can be used to control other hypervisors, and that is what we're going to focus on. There are multiple ways to access the hypervisors as well as vCenter. One common way how threat actors love to access these and how defenders also sometimes access these is secure shell login, SSH. SSH is not enabled by default, but often defenders and system administrators enable it because they want to use it, and threat actors enable it because they want to access these hypervisors over SSH to deploy encryptors. Web browsers is often how these are connected to. There is a direct control user interface, and then there is an API, which is again used by defenders, system administrators, and also used by threat actors. ESXis can be integrated with Active Directory. In this case, once you integrate your ESXi hypervisor with Active Directory, there is a need of creating a group in the Active Directory. By default, that is called ESX admins. And whoever is member of that ESX admins will then have admin access to hypervisors. These are the four techniques which we're going to talk about today. First, we're going to look at ransomware, how e-crime threat actors can deploy ransomware to encrypt machines at scale. And then we'll look at how nation-state threat actors often make sure that they have access to guest virtual machines through the ESXi host using VIX API. We'll look at covert persistence through malicious webs, and then we'll look at a novel way of targeting vCenter server to extract some credentials and then use those credentials to access the ESXi host. Buckle up, we're going to go through this pretty quickly. The only limitation we have is time here. So we're going to go through this fast, but then the slides are available for you to have a look. Let's get started by looking at ransomware targeting ESXi. This has been a very big problem for past couple of years. Ransomware threat actors have been targeting ESXi to encrypt virtual machines at scale. The way usually this happens is a threat actor gains access to the ESXi over SSH. Either the SSH was enabled by a system administrator or the threat actor accessed over the HTTPS and enabled that SSH option. Once they are in, they copy the encryptors, typically to a staging directory, and then they kill the virtual machines that are running. Why do they do this? This is an important critical step in this process. When the VMs are running, they are not accessible from other binaries. So you cannot encrypt virtual machines unless they are powered off or they are killed. That's why threat actors do this. Once they have done that, they execute the encryptor. They're targeting VMFS, the volume folder. That is the folder where virtual machines are stored in the form of disk files. And once they have done that, they have essentially encrypted the entire virtual VM store, and they also sometimes delete logs. That's the step-by-step process of what they usually go through when they are targeting hypervisors. Let's now look at some of the host logs that are available on the ESXi host. Now, while we are talking about these logs that are available on ESXi in this section, this is applicable for all the attacker techniques which we're going to talk about. This slide is a reference slide. This talks about the main important log files which are available in ESXi hosts. I'm going to talk about some of the specific ones which are of more interest. Let's first look at syslog.log. Sys.log.log is a log file which is available in /var/log, and it records all the general system log messages for the ESXi. I would say not a very big help for forensics, but typically used for troubleshooting. There are better log files you want to look at if you are performing forensics, like this one. This is auth.log. This records all the SSH authentication events for the ESXi host. So in the yellow highlighted, you see a connection came from 192.168.1.18. Then you see an invalid user admin try to log in. And then you see root account coming in from 192.168.1.18. So this is recording authentication over SSH. Shell.log records everything that was run. So if a threat actor gained access, what did they do? You want to figure that out. What encryptor did they run? What commands did they run? That's your file to look at. This one, which is hostd.log, is the one which records every kind of authentication. I talked about SSH logins, web browser logins, API logins. All this gets recorded in this hostd.log file. What I'm using here is PowerCLI, which is something which is provided by VMware to log in over API. And then I'm using Python SDK, and both these events get recorded in this file. This is another file which I like to mention here. This is vmkwarning.log. If there is a time zone change, if someone changes times on ESXi's, that will get recorded here. Threat actor may want to do this for time stomping purposes, but anyway, it's trivial to do that on Linux systems. Those were some of the log files which we wanted to talk about. Now we're going to talk about our second technique, which is abusing VIX API to access the guest virtual machines that are running over the ESXi host. So the host is ESXi hypervisor. The guests are the VMs that are running over it. The way this works is if a threat actor has gained access to ESXi, they can use the VIX API, which is provided by VMware as a part of managing guest machines to access the ESXi guests. One thing to note here is this can be used even if guest operating system networking is disabled. If those VMs are contained using an endpoint security software, this will still work because this is using VMware tools that is present on the guest VM. Let's see how this looks like. Here, I'm following a 4-step process. In the first step, I'm connecting to the ESXi server. I need the credentials of the ESXi server to connect to it. So that's what I'm doing here. Line 2, I'm copying a Mimikatz executable to the guest over the VIX API. So I've already connected to the bare metal hypervisor, and now I'm using that access plus the credentials I have. This does require credentials for the guest virtual machines to move it into the guest virtual machine, and I'm copying this file. Then I'm executing Mimikatz. And final step 4, I'm copying the output of the Mimikatz, exfiltrating it out so that I can crack those hashes which now I have access to. This is just an example. Things to note here. 1, you need credentials to the hypervisor. Second, you do need guest credentials to access the guest. And this still works if the system is isolated. Let's look at some of the logs that get generated, or where can you detect this kind of activity. If you have visibility on your guest virtual machines, which a lot of organizations do have these days, if you are running an EDR or do have logging enabled, this will come up. On the right, this screenshot shows that the process that was executed, which was a PowerShell.exe process, because I was using VIX API, PowerCLI, the parent of that was vmtoolsd.exe. This is not common in environments. Sometimes it comes up when tools are getting updated, but this is a detect which can be used to see if someone is using VIX API. On the left, you see the logon. So there's a logon type 4 event that is created on the guest virtual machine, and that event is coming from the process vmtoolsd.exe. So if you have guest visibility, you can use this guest visibility to perform this detection. Now let's look at what happens in the log files that are available, both at the hypervisor level as well as the guest level. VMware.log file exists in the volume folder. So volume folder is the folder where the disks are on the hypervisor. And that particular file records guest operations. So what you see here in yellow is guest ops, create temporary file, start a program, list processes, initiate file transfer. All that is being recorded in the VMware.log file. Threat actors can tinker with this. They can disable it, but in the default configuration, this log does get created. Now I was talking about some guest operations. So these guest operations are available on the SANS website. This is a list of those guest operations. The guest file manager, guest process manager, this is for reference again. So that was the VMware log file. There are other files which you can enable. Now, this is not enabled by default. This is debug logging, and this exists in the guest virtual machines. Now we are talking about guest VMs, not the ESXi host. If we enable the debug logging and provide a file in which we want the logs to be written in the tools.conf file in the guest VM, we can have these logs created, and you can forward this over syslog. Once that is done, you will see a log file like that. Here, I've logged in as a user called administrator in the guest VM, and I'm using opcode 186 and listing processes. What's this opcode 186? That's opcode 186. So there is OpenVM tool source code, which notes down what opcode means. And you can refer this link here and see that what opcode means what VIX command. And now with this additional information, let's look at a couple of more examples. Here, I'm commanding to start program in guest virtual machine. You see command 185. You see the command.exe was executed, PowerShell was executed, and there's that base 64 PowerShell blob that was eventually run on that virtual machine. So this all information is available in the debug file, and the opcode is 185, and now we know what those opcodes mean. Here is another example here. Once I've run that command, the mimikatz command, and I created that file which contained credentials. Now I'm copying that out, and you can see that administrator is copying ctemp_dump.txt, and the opcode here is 188, which is file transfer from guest. So all these logs would be available. Now remember, when I started, I said you do need access to the hypervisor, and also you need credentials for the guest machines. Yep, you normally do need that. But there was this vulnerability that was identified a few weeks ago in VMware tools, which allowed threat actors to bypass that requirement. This vulnerability is in the known exploited vulnerabilities catalog of CISA. So this is being exploited in wild. Moreover, a lot of times VMware tools is not updated. So I'm hoping against hope that this will be patched, but this may have a very long tail, and this may be exploited for a very long time by threat actors. That takes me to VMware vCenter, and I'm going to hand this over back to Thiru for him to talk through the next few slides.
Thank you, Anurag. Let me check if I can manage the decks. All right, let's move to the next section, vCenter. So vCenter is a management server predominantly used to support and manage ESXi host and the associated virtual machines. Once the ESXi host is integrated with vCenter, vCenter will have administrative permissions over the ESXi host. Threat actors, when they compromise or attack vCenter, they have administrative permissions over the ESXi host, as well as they control the associated virtual machines. Once ESXi host is integrated with vCenter, it creates a user account called VPX user in the ESXi host. And this account password is stored in vCenter. So vCenter will leverage these credentials in order to manage ESXi host. The password is changed every 30 days once in a periodic fashion as well as in an automated fashion. So this account has administrative permission over the ESXi host. Threat actors can extract the password of VPX user account in order to have access over ESXi host, as well as to manage all the virtual machines associated with the ESXi host. As I referred earlier, this account's password is stored in an encrypted format in the vCenter on vPostgreSQL database. The key for the encrypted password is stored in a file called simkey.dat in vCenter. So threat actors can decrypt the password, and with that, they can log into the host. Now I'm going to explain you how the attack flow of how threat actors extract the password of this specific account. First of all, threat actors need root access in vCenter in order to retrieve the password. As a first step, they can access files like vcdb.properties in order to understand the Postgres database details, as well as they can connect to Postgres database through PSQL utility. And they can issue this query to retrieve the encrypted blob, which is the encrypted password. And then they can retrieve the key from the file simkey.dat. Now with all these details, they can leverage the public decryption tool in order to decrypt the password. Threat actors with the password, now they can directly SSH into the ESXi host at will. Now let's talk about the logging, right? The PostgreSQL logging is enabled by default. So this will record if any connection is initiated to the PostgreSQL database. But the default setting will not record any queries or SQL statements that are executed within the database. In order to record the queries, you need to tweak this file, PostgreSQL.configuration. You need to add a value all to the parameter log underscore statement. And then you need to restart the service. Once this change is applied, the PostgreSQL logs will start recording all the queries, all the SQL statements executed within the database. The caveat here is this generates humongous of log, and it's very noisy. In addition to the PostgreSQL logs, see, these are other important logs that we strongly recommend you to collect and monitor. VI events, so that's a vCenter events. So this records all the actions performed by vCenter. You can view these events by accessing the vCenter portal, as well as you can retrieve the events through Power CLI queries. Now let's talk about VIPs. VIPs stand for vSphere Installation Bundle. So this is a collection of package into a single archive file to promote distribution. So typically ESXi host is patched through WIB files. Each WIB includes three important components: file archives, so that's the actual payload; descriptor file, which is in an XML format, so that describes the content of the WIB. Third important component is signature file. So that's a digital signature associated with the WIB to verify the level of trust. Each WIB has an acceptance level associated. So that denotes the integrity of the WIB and who created this WIB, what type of testing and verification is performed. There are 4 acceptance levels. VMware certified WIBs are created and tested by VMware. VMware accepted WIBs are created by VMware partners approved by VMware. Partner supported WIBs. So these WIBs are created and tested by trusted VMware partners. And this is the minimum acceptance level configured in the ESXi host of the default setting. Community supported WIBs. So these WIBs are created by any individuals or partners outside of the VMware partner ecosystem. At any given time, administrators can change the minimum acceptance level to any of these values. ESXi host operates in an in-memory file system. So not every installations can persist after the reboot of ESXi host. Installations through WIB files can persist after ESXi host reboot. So threat actors can package their malware or backdoor files in a WIB package and they can install it. But for that, they need a root privileges over the ESXi host. Mandiant have identified a backdoor which was written in Python. We named it as a virtual pipe. So threat actor packaged this backdoor and installed it on one of the compromised ESXi host. As I referred earlier, the partner supported web is a minimum acceptance level in the default setting in ESXi host. So in the default setting, the community supported webs cannot be installed in the ESXi. Whereas VMware is offering a feature where you can forcefully install a web below the minimum acceptance level set in the ESXi host. So by just adding an -force parameter during installation. So defenders, you can leverage this query and you can list out all the install webs, associated acceptance level, as well as the signature verification status in the web. In order to query all your ESXi host at large scale, you can leverage the PowerCLI script issued by VMware, through which you can query all your ESXi hosts at scale to identify installed unsigned webs. Now let's talk about some additional ESXi artifacts. You can leverage this query to list out all the files that exist in the ESXi file system. This will also include the timestamp details of each files, like accessed, modified, and metadata change timestamp. Once you know the incident timeline, you can correlate and identify what are the files accessed and modified during the incident time range. So deleted file is not listed as a part of this query, as well as the file creation timestamp is also not recorded. As I referred earlier, ESXi operates in an in-memory file system. Certain logs get reinitialized after reboot. So we need to archive all these logs into a persistent storage partition. So during the default ESXi installation, there's a partition called Scratch is created. And that's a partition has 4 GB in size, which you can extend depends upon your requirement. So as an investigator, we need to access the Scratch partition and we need to pull these logs in order to understand the historical activity that happened in ESXi host. _history. So this records all the commands that are executed within the shell. And this specific file will also get reinitialized after the ESXi host reboot. So cron is a utility which you can leverage in order to create jobs to automate execution of scripts or commands during a specific time period. So you can use this query to list out all the cron jobs created in the ESXi host. And then you can identify the suspicious job created. So we talked about different attack techniques. We talked about logs and other artifacts that you can leverage for investigation process. Now let's talk about how to defend ESXi host and vCenter. We strongly recommend you to disable SSH and shell access to ESXi host and vCenter. You can also disable internet access over the vSphere infrastructure. You can leverage the built-in firewall capabilities to restrict access to ESXi host and vCenter only from the limited approved IP ranges. You can implement dedicated privilege access workstations in order to administratively access the vSphere infrastructure. Let's talk about how to restrict malicious web execution in ESXi host. You can enable UEFI secure boot. So this feature will restrict loading of any unsigned webs during the booting process. Not only that, this will also prevent if someone tries to change the web acceptance level, as well as if someone tries to forcefully install a web. So we strongly recommend you to enable this control. Now let's talk about how to restrict non-web binary execution in ESXi host. When I talk about non-web binary, I'm referring to ELF binaries or shell scripts. Typically, ransomware binaries are in ELF format. You can enable exec install only setting through kernel options. And in order to apply the change, you need to reboot the ESXi host. Once exec install only setting is enabled, this will not permit execution of any non-web binaries. And this will also record the restriction actions in the mentioned log files. And that's a gold spot for the SOC team. So that's a good part. The bad part, the Python scripts are allowed to execute. So exec install only setting will not restrict execution of Python scripts. So Python-based ransomware files or any malicious binaries created through Python can circumvent this control. And not only that, so threat actors with root privilege, they can disable exec install only setting, but eventually they need to reboot the box. There's a major change that happened from ESXi 8.x version onwards. Exec install only setting can be enabled through kernel option as well as through runtime option. Enabling and disabling the exec install only setting through runtime option may not require a reboot. The changes will apply instantly. From vSphere 7.0 U2 version onwards, the ESXi configurations are stored in an encrypted format. So though threat actor get access to a storage component, still they can't tamper the configuration. So that's a cool control. And by default, the configuration is encrypted through key derivation functions. If at all you use trusted platform module, which is a crypto processor chip, so that will also encrypt the configuration as well as manage the encryption key separately. Not only that, TPM can send attestation reports about the ESXi host to vCenter. So through a centralized fashion from the vCenter, you can access and review the state of all your ESXi hosts. You can also enforce exec install only setting and secure booting setting. And if that is enforced, TPM will make sure to enable these settings during the booting process. We have seen organizations, they generally disable SSH service in ESXi host, but still they allow web services. Threat actors can enable the SSH service back by just making API calls. So that's why we recommend you to enable lockdown mode. When a lockdown mode is enabled, it will enforce all the ESXi host operation to be performed only through vCenter. So there are two settings: normal lockdown mode, where the ESXi host is accessible through console as well as through vCenter. In a strict lockdown mode, ESXi host accessible only through vCenter. And you can also add users to the exception user list so that they will not lose their permission when the host joins a lockdown mode. And VMware recommends not to add administrative accounts to these exception lists. We have taken this snapshot from VMware website. So this clearly explains the lockdown mode behavior. And this table lists out user accounts that has access over different services based on the ESXi that joins to the lockdown mode. Okay. We strongly recommend to set a unique and a complex password for all the local accounts in your vSphere infrastructure. And if at all you use PAM solution, try to vault your root account password and rotate it periodically. And if ESXi host has joined your Active Directory domain, make sure all the management activities are happening only through vCenter. This can be achieved through lockdown mode, as I referred. And in addition to that, you can reduce the exposure of ESX admin group in your Active Directory environment by just changing the default naming convention. And we also recommend to have a dedicated identity solution in order to manage your vSphere infrastructure. You can enforce and you can perform multi-factor authentication while your administrators access vCenter portal, as well as when they're making API calls to vCenter. Some of the version have started supporting smart card, RSA secure ID, DO, MFA solutions. In addition to that, you can also federate vCenter portals and web APIs with your ADFS or Okta solutions, which support other MFA products. We talked about different logs. So we recommend you to collect these logs and monitor through your SIM solutions. Critical events like someone enabling SSH should be treated as a high severity alert. Implement immutable backup and make sure you secure the immutable backups in an air-gap network so that you can avoid suspicious access over the backup files. And you can also perform multi-factor authentication if you need to access the archived backup files. You can disable VIX API guest operations in the guest VM configuration. So this will restrict ESXi host performing guest operations over the virtual machines. There is an impact. VMware Consolidate Backup Service and the Update Manager needs to perform guest operations over the VM machine. So these services may get. You can also create custom roles and assign to user accounts by restricting certain guest operation actions like executions. You can perform Yara scan against the ESXi host. You can mount ESXi host to your DFAR Linux machines using utilities like SSFS. And once you collect the malicious artifacts from the compromised ESXi host or from the open source intelligence, you can create Yara rules based on the artifacts that you have collected. And then you can scan the mounted ESXi host. to understand whether it is compromised or not. We are pretty much to the end of this session. We really appreciate your time. Thanks a lot for listening to our talk. Kindly reach us for any questions related to the talk. Thank you.